Hi, this is Kevin. I'm back with part two of the tutorial for chapter 8 of the third edition of the Zelle Python programming book. And in part two, we're going to do a program that's an adaptation of the one we did in part one. So back in part one, we created a program Sentinel loop using break, and here we're going to create one that's called Sentinel loop without break. So let me copy in my already baked version, so then you don't have to watch me type quite so much. Okay. And of course, in my tutorial version, I've got the word tutorial in front of the name. And I just want to point out that this is a refactoring. Okay. A refactoring is when we change the code. We don't change to affect the behavior at all. Okay, and we change the code because we want to make it more readable, more maintainable, more testable, right? So what have we done here? Well, we've gotten rid of the break statement. There are quite a few people, myself included, who are not big fans of the break because it violates technically one of the provisions of the rules of structured programming, and that rule said each piece of code should have only one entry and only one exit, and kind of implied the exit should be all the way at the bottom. Okay, so the really strict interpretation is one exit at the bottom. Okay, well, break does not comply with that. Okay, so there's a less tricky way to do this, which the the strong adherents of structured programming, of which I'm one, believe in, and that is that what we ought to be able to do is in our code, in just the place where we would have put a break, we ought to be able to set an indicator. In this case, what we were trying to detect was the end of input. So we ought to be able to set an indicator, typically a Boolean. So we have created one called end of input. We give it an initial value of false, okay? And when it detects the end of input, we then we set the indicator to true, okay? And then we ought to be able to detect that end of input up in the while. Okay? And that's all we're really doing here. That's all that changed, right? So instead of saying break here on line 15, we're saying we're setting end of input equal to true. We had previously initialized end of input to false. And then the while loop, it doesn't seem so surreal. Anytime I have to code while true, it seems like it might run for the rest of our lives and into eternity. Whereas this is more explicitly what's really going on. So this is a better expression of what's actually happening. So we say while not end of input. So it's going to go round the loop here until we detect the end of input. Okay, we turn the indicator on. And then we come down, we finish out the body of the loop, and then we detect it the next time through, in which case we drop through to the final processing. Now, for this to work well, we need to have put the work that's in the body of the loop on the else of the if that detects the end of input. Okay, we would not want to do our loop body processing after we detected the end of input. Okay, so what I've been doing, if you look at the way I structured the first version of this, I got I I set the code up in a way where we would just be ready for that. Okay, so we didn't really have to change anything at all. I guess we changed this code on line 15. We change the condition for the while, and we initialize end of input to false, and then it should work the same. Okay. So this refactored version, why do we like it more? It's better documented. Okay, it's more consistent with what have been considered good programming practices for, well, certainly 45 years, a long time. So that's why I like it better, and that's why I'm teaching you to follow this approach. So hence this refactoring assignment. Okay? All right, so let's give it a test. Again, the first thing that we want to test is no input at all. So let's do that. So we get no input. Then we say there wasn't any input. That's good. All right, and then let's do a test again, and let's give it what? 3 less than 0, minus 3, minus 2, minus 1. 1, 0. And then let's have 5 greater than 0. 1, 2, 3, 4, 99. And then let's signal end of input with just a return. And that's what we get. We get 3 less than 0, 1 equals 0, 5 greater than 0. So that worked just fine. Okay? So this is pretty straightforward. This is a good programming practice. And this is a good opportunity for us to think about refactoring. Okay? You should always when you get to the end of working on a program, you should always say to yourself, well, what could I refactor here? What would be better for people who come along to test this or to maintain it or to make modifications to it? What would be better for them to have? The version I have right now or one slightly refactored version? In this case, we decided to go with one more refactoring. Okay, that's it. It's your turn to do it on your version, and I'll see you in part 3.